we are asked to differentiate this function. And we know that they are product of the exponent plus 2x plus 1. So immediately, you can assign u and v here. Now, this is what we call the product rule. If you are not familiar, then you can go back to your textbook and have a look. This is called product rule. So we let u equal to e to the 2x, v equal to 2x plus 1. Now again, you should differentiate this. Now to differentiate this, if you look at the formula booklet on the same page that I just showed you just now, if you differentiate e to the fx, there are only 2 steps. Copy down whatever it is. So you leave some space and then copy down whatever it is and bring the top to the front and differentiate it. Okay? This formula is in the booklet. So you can have a look on the back because I have attached the formula booklet to you. So let's do that. U dash, copy whatever it is, and then bring it up, differentiate. 2x, you differentiate it, it becomes 2. And then for v dash, differentiate 2x plus 1 become 2. Now, it's not done yet because we are trying to differentiate this whole thing. So you write d, you want to differentiate, write d dx, the whole thing. Then you use your product rule, which is u dash v plus v dash u. Now, how do you know which one to differentiate first? Because you're always confused with the quotient rule. The rule is very simple. Whichever, this rule or this rule, you just differentiate u first. Always start with u first. You differentiate u first, okay? So now you can just copy down. U dash is 2 e to the 2x multiplied by v, which is 2x plus 1, plus v dash, which is 2, and u is e to the 2x. Now, we can see that you have 2e to the 2x here and 2e to the 2x here. So we can factorize it. So when you factorize this out, whatever you left is this one. So we copy down. When you factorize this one out, you only have 1 left. So plus 1 as well. So it's 2e to the 2x, 2x plus 2. And again, you have 2 here and 2 here. So you can bring the 2 out again. 2 times 2, which is 4. And this is your answer. Okay? Now remember, a lot of students like to just differentiate this. Like they just write it down, this one and this one, without writing this one out. Now it's important to write this one out because you are telling people you are differentiating this function. If you just write the answer out, nobody knows what you're doing, and the marker doesn't know you. He doesn't have the responsibility to look for your answer. So it's always to be more formal, write out whatever you think and write out whatever they should know, okay? You need to stand on the perspective of marker so you can get more marks. It's easy for the marker to mark your solutions, okay? Always remember to write the complete solutions. Now, this is just the first part. I'm gonna zoom this down. Right here. Now, the second part, we are asked to integrate this. Now, don't be terrified. So whenever you are asked for the first part and then you say hence, it means immediately you know this question requires this part, okay? It requires the solution for the first part. So, x plus 1 e to the 2x dx. Now notice that, do we have this one here? This one is similar to this, it's exactly the same as this one, right? So this one is same as this one. We can rearrange the top. So we know that, let me rewrite. It's 4e to the 2x, x plus 1. So we want this one. So let's rearrange, bring this to the other side. So e to the 2x, x plus 1 equals to a quarter of the whole differentiation. So we're going to sub it in. Okay, we're going to sub this whole thing in. So integrate 1/4 differentiate e to the 2x, x plus 1 dx. Now 1/4, the quarter is constant, so I bring out 1/4. Now, this is the tricky part. Differentiate this, become this. Now you differentiate and then integrate. We know that integration is the reverse process of differentiation, right? Integration is just the reverse process of differentiation. So now you differentiate and then you integrate. What does it give you? You differentiate and then you integrate. What does it give you? People, can you answer me in the chat box? Now you integrate and then you differentiate and then you integrate back. So it would just give you the same thing because as I say, integration is just the reverse process of differentiation. So you can just write out 1/4 e to the 2x, x plus 1, and plus c. Now, I forgot to mention, whenever you integrate, whenever there is no number here, there's no limit, we call this limit. If there's no limit, you need to plus c. This is very important. You will lose mark if you don't plus c, okay? All right.